Every week, and in all weather, boats sail from major ports and from small harbours around our coast. Their purpose is fishing. These vessels of differing types and sizes have one aim in common. They are going to sea to hunt wild fish in order to bring them ashore for sale. There is a great variety of fish, each requiring special vessels, fishing gear, techniques, and skills. Fish forms an important and healthy part of our diet and is strongly recommended by nutritionists. Fish of all types make up one of nature's great gifts for the feeding of our population. But there is a shadow hanging over the fishing industry. The mortality rate among fishermen is high. Losses of fishing vessels at sea are commonplace. Quite simply, commercial fishing is the most dangerous of all occupations, with fishermen and women being 110 times more likely to lose their life at work compared to the average employed worker. Why should fishing boats be such dangerous places in which to work? The answer lies with the stability of the vessel, defined as the ability to return to the upright position after being displaced by wind or waves. From the vessel diagram, it can be seen that the downward gravitational force W through the centre of gravity G and the upward buoyancy force are equal, but the buoyancy acts through the metacentre M, giving a righting lever GZ. As G approaches M, the righting lever GZ is reduced, and the ability for the boat to right itself is lost, so it is essential that G is kept as low as possible. It is believed from accident statistics that 60 to 70% of vessel losses are due to inadequate stability. Marine Accident Investigation Branch statistics from their 2018 annual report are shown here. It can be seen that there were 38 crew accidents, including 6 which resulted in death during the year. There are many causes of instability which can occur, including the weight of fish on deck, water trapped on deck, water ingress to the hull, ice accretion on the superstructure, free surface effect from partly filled tanks, and excessive weight above deck, including any crane load. Here we can see the effect of a slow leak of water into the hull on this Seafish model while carrying out one of our early tank tests. The centre of gravity is moving and the stability of the vessel is reduced. So what can be done to make fishermen aware of this vital yet hidden factor while they are at sea? Scottish company Hook Marine Limited has developed a new instrument to monitor the stability of a vessel while at sea. The monitor measures the roll period of the vessel and relates it to the metacentric height GM. And to illustrate the instrument output and relate it to the vessel's stability, we have again used the Seafish model. The model is floated in a tank with the water agitated by a pump and a rolling motion created. The SeaWise screen appears like this. Spot values for the roll period and the GM value are shown. The trace of GM indicates that the stability is satisfactory, with the GM graph running above the 2 alarm levels. The traffic light shows green. The net drum is in the lowest position. The net drum is then raised to the intermediate position. The GM value drops. The roll period increases, the GM trace moves below the amber alarm set level, and the traffic light turns to amber. The net drum is then raised to the top position. The GM value drops again, the roll period increases, the GM trace moves below the red alarm level set, and the traffic light turns to red. A red light is activated below the IMO recommended value for a fishing vessel, normally 0.35 metres or 0.5 metres for a beam trawler. When the red light appears, an audible alarm sounds at the same time. A red light is the signal for the crew to identify the cause of the declining GM and to take appropriate action. SeaWise therefore acts as an early warning device, and the crew are given the opportunity to take remedial action or to broadcast a Mayday message. And so fitting a SeaWise unit will safeguard the lives of the crew and will preserve the value of the vessel, securing the owner's investment for the future. Before hauling the net, the skipper will know the vessel's stability reserve and can take an informed view of the safety of his actions. With the catch on board, it should be stowed below deck as soon as possible in order to keep the centre of gravity low, thus increasing the value of GM. A careful watch should be maintained on the SeaWise screen, even during the return to port where the catch will be discharged. It should always be remembered that the consumption of fuel and water from low tanks during a voyage will reduce the measured GM, and the crew should be aware of this fact. A stable vessel is a safe vessel. Be stable, be safe.